Hello and happy Monday. I'm going to go over the instructions with you today and also a little bit of notes about length so that you can proceed with the length lab while I'm not here today. First, you should have already picked up a paper that has the length notes, and at the top of that paper is a before and after lesson true-false activity. So on the left-hand side, you are identifying if these statements are true or false simply by circling T or F. At the end of the lesson, you're going to go back and do this again. If you realize along the way that you were wrong, you don't need to erase, you don't need to make any changes, because at the end of the lesson, you'll be able to show what you have learned. So right now, you're just showing me what you already know. Now, below the true-false is some information about length. So we're going to go over that together right now. The definition of length is the distance from one point to another. So you're going to add that definition with your pencil, and if you or the teacher needs to pause this video so that you can add that definition, you may. But length is a measurement of distance. It's simply one dimension, distance from one place to another. And we measure really teeny tiny little distances as well as enormous distances around the Earth, around the universe. So we've talked about metric units, and we already know that all metric units have one base unit. The base unit here in the center for length is the meter, and we abbreviate meter with the letter M. So let me write that in. Then we move from our base unit, and we can either chop it up into tiny little pieces and move into decimeters, centimeters, or millimeters, or we can multiply meters and have multiple chunks of meters. 10 would be a decameter, 100 meters would be a hectometer, and 1,000 meters is a kilometer with that prefix kilo. So first, let's remember what a meter is. If you've ever seen a meter stick, you're familiar with the length of a meter. It's approximately the length of a baseball bat or the length of a guitar from one end all the way to the other end, or the height from the floor to a doorknob. Here's my science storage room door. From the floor to this doorknob is almost exactly 1 meter stick, or 1 meter. Now, let's go small first. When we chop 1 meter into 100 little pieces, each of those pieces are called centimeters, which we abbreviate cm. A centimeter is about the width of one fingertip, and it's also about the length across a dime, a coin, a dime, or a Cheerio. One little Cheerio is about the size of a dime. It's about 1 centimeter. When we're measuring things later today, if I ask you to measure a small distance that you can measure with a centimeter, make certain that you're not measuring in inches by taking a look at your ruler and making sure that the 1, from the beginning of the ruler to the 1, is about the length of your finger. If it's bigger, if it's almost 2 finger widths, you're probably looking at the inches side. So when we measure in centimeters, we want to make sure it's about 1 finger width, or a dime or a Cheerio. You're going to be writing in these examples as well. Now we can take a centimeter and chop it into 10 tiny little pieces, and all of those tiny little pieces are called millimeters, which we abbreviate MM. Millimeters. Milli means thousandth, so it's 1,000th of a meter stick, or it's a 1/10 of a centimeter. A millimeter is tiny. Here I mentioned a dime again, but it's this time the width of a dime. If you turn a dime on its side and you look how thick it is, it's the thickness of 1 millimeter. I'm not sure how much experience you have with pins, but you know, pins and needles, pins can have like a little tiny little ball at the end, and that is as thick as 1 millimeter. Or a pencil tip. A pretty sharp pencil tip actually is going to be the width of a millimeter. So the millimeter is the tiniest unit that we're going to use, but in the metric system we can continue to divide by tens, and we can continue to get smaller and smaller units, which are used for measuring things like parts of cells and atoms. Let's move upward. We talked about how some of these units are just not very popular. It's not very helpful to use a decameter. It's just not commonplace. but kilometers are very frequently used for long distances. So I'm going to abbreviate that, km for kilometer. And kilometers are used anytime using a meter stick again and again isn't practical. So 10 football fields from one side to the other, 10 of them makes up 1 kilometer. The distance around a small pond, that's incredibly vague, but it could be pretty close to 1 kilometer. Or very specifically, exactly 2.5 laps around a track is going to be 1 kilometer. Each lap is 400 meters. So going around 2 times gives us 800 meters. Going around another half a time brings us to exactly 1,000 meters, which is a kilometer. So you may pause this if we need a little bit of extra time to make sure that we have at least 3 examples written for each of these units. All right, now just to prepare yourself before you begin your labs, when you are following the directions on the lab, you need to be very careful and pay attention to what units I'm asking you to measure in. Sometimes I ask you to measure in millimeters, sometimes centimeters, and sometimes meters. I'm never going to ask you to measure in anything else during today's labs. When you are getting started measuring with centimeters, again, make sure you're looking at the side of the ruler where the centimeter markings are 1 finger width thick. If it's bigger than that, it's probably inches, and we are not using customary units in science class. We are only using metric. So find the centimeters. If I ask you to measure this blue line in centimeters, we can find out the closest labeled centimeter marking that the line goes to. So in this instance, we're making sure to line up our ruler to the very start of the object, the very start of the line. And then we can see this goes past the 5. It even goes past 5.5. So it's closest to 6 centimeters. This is not from your paper. This is just an extra example to show you. Now, if I asked you to measure this line with millimeters, now we're going to pay attention to the tiny little markings. Now, we could pay attention to exactly where this blue line ends with these little markings, which is like right about here. And technically, we could count every single little millimeter marking to find out exactly how much this is, but that would be a waste of time because we know with the metric system, everything is divisible by tens. That's why we love the metric system. So 1 centimeter we already know is 10 millimeters. So we can count by tens to get as close as we can. So 1 is going to be 10 millimeters, 10, 20, 30, 40, 50. We know for sure that this line is at least 50 centimeters long. It is not 60. We can't just pop a 0 in there and call it a day. It does not go to here. When we measure in millimeters, we can be really specific. So we know we've got 50 millimeters plus a few more. We know that halfway through a centimeter is 5 more. So we can be confident that we've got 55. And then we can count the rest of these markings. 56, 57 millimeters. For some of you, this may feel a little silly and redundant because you've been measuring in metric for a long time. But some of you have never done this before, so this feels very brand new, and that's okay. That's why we're doing it. This line could be rounded to 6 whole centimeters, or to get specific, we could say that it's 57 millimeters long. Both of these are accurate statements. So on your small length lab, make sure that you pay attention if I'm asking for centimeters or millimeters. On the large length lab, pay attention if I'm asking for meters or centimeters and use those same skills. While we're doing this lab, you are only going to do one of the labs today. You're either going to be a small lab person or a large lab person. Tomorrow, we'll pick up where we left off, and you'll do the lab that you didn't get to do today. So you're going to see the group that you're working with. You need to stay and work with your partner the entire time. You are not just doing it by yourself while they do it by themselves. You're sharing tools. You're working together. Sometimes you actually need a person to help you save the spot where your meter stick is so that you can move the meter stick and continue measuring. Work together. Take turns. Follow the directions, make sure you know what units you're measuring in, and do not measure in inches. No customary units. When the teacher reveals the groups, if your group is blue, you're starting with the small lab and you're only doing the small lab today, you'll do the other lab tomorrow. If your group is yellow, you're going to do the large lab first and you're going to do the small lab tomorrow. So pay attention. Be calm and quiet in the classroom as you work so that everyone can focus and do their best. And happy measuring.